At first glance, railroad tracks look boring. Two steel rails side by side running off into the distance. They don't have any flashy parts or wild curves. If you've ever stood near a track, you might wonder, how hard could it be to make something like that? This simple look hides a world of clever engineering. Beneath that plain surface is a system that keeps trains moving safely. Every piece is designed for a reason. The rails, the ties, the gravel, all work together. But the real magic lies in how the wheels and rails join forces. Trains are heavy. Some weigh thousands of tons. Yet these metal wheels glide along the rails, mile after mile. No steering wheel, no tires, just steel on steel. It's amazing that such a basic setup can move so much. So why do trains stay on track? And why don't their wheels look flat like car tires? The answers show just how smart train engineers really are. Unlike cars, trains can't steer left or right. They're locked onto their tracks, following a path that's been laid out for them, no matter where it twists or turns. There's no steering wheel in the driver's cab. Instead, the engineer controls speed and braking, but not direction. The train's path is fixed by the rails, which act as a guide, ensuring the train follows the exact route intended. This makes train design very different from anything on the road. Unlike cars, which rely on steering and flexible movement, trains depend entirely on the track beneath them. The wheels have to do all the work. They keep the train rolling straight and help it turn corners, all while supporting massive weight and maintaining stability. Imagine driving a car where the wheels can't turn at all. That's the challenge trains face every day, relying on engineering rather than steering to navigate curves. This means that every part of the wheel and rail system must be perfect. If anything goes wrong, the train could go off the rails, making precision and maintenance absolutely critical. Engineers had to find a way to guide these massive machines using only the shape of the wheels and rails. It took years of innovation and testing to get it right. It's a clever solution. Instead of moving the wheels, they shaped them in a special way, giving them a slightly conical profile that helps the train stay centered on the track. The secret is not in fancy technology, but in the way the wheels and rails touch each other. This contact is carefully engineered for safety and efficiency. This perfect fit is why trains can travel safely at high speeds, even around bends, without steering. It's a testament to the ingenuity of railway engineering, allowing trains to glide smoothly along their tracks. Have you ever noticed that train wheels aren't flat? It's something most people never think about, but it's a fascinating detail that makes a huge difference in how trains work. If you look closely, you'll see they are shaped like a shallow cone. This subtle angle is easy to miss, but it's crucial for the train's performance. Instead of a flat surface, the part that touches the rail is slightly sloped. This sloped surface is called the conicity of the wheel, and it's a key part of train design. This conical shape is not an accident. It's one of the smartest choices in all of engineering. Engineers discovered that this shape solves several problems at once. The cone lets the train handle curves without sliding off the rails. It's what keeps trains stable, even at high speeds and on sharp bends. Here's how it works. When a train enters a curve, the wheel on the outside of the curve rides up the slope. This means it sits higher on the rail, almost like climbing a gentle ramp. The inside wheel, meanwhile, rides lower, staying closer to the center of the rail. This difference in height is what allows the train to turn smoothly. Since both wheels are fixed on one axle, they must spin together. Unlike a car, where each wheel can rotate independently, train wheels are locked in sync. But the outer wheel has a longer distance to travel on a curve. If both wheels were the same size, this would cause slipping or skidding. Thanks to the cone shape, the outer wheel rolls on a larger diameter, so it covers more ground with each rotation. This clever design matches the longer path perfectly. The inner wheel, on a smaller diameter, moves less. This difference in rolling distance is what allows the train to glide through curves without any trouble. This lets the train round the bend smoothly, without jerking or grinding. It's a seamless motion that passengers barely notice. The cone shape keeps everything moving smoothly, with less noise and less wear on the wheels and rails. Over time, this saves money and keeps trains running safely. It's a small detail, but it makes a huge difference. Next time you see a train, remember, the magic is in the cone. Rails might look flat, but they have a shape too. The top of each rail is rounded, not flat. This is called the railhead. It matches the curved shape of the wheel's tread. Why does this matter? The rounded railhead spreads the train's weight. This helps prevent dents and cracks. It also guides the wheel, making sure the train stays on the track. The rail's shape also helps reduce wear. A flat rail would dig into the wheel, causing damage. The matching curves mean smoother rolling and less friction. Less friction means less energy is lost and less heat is generated. Engineers have even designed different rail profiles for different speeds and loads. Every detail is planned for safety and strength. Rails and wheels are a perfect team, built for the long haul. So let's take a closer look at a train wheel. At first glance, it might just seem like a simple round piece of metal, but there's a lot more going on beneath the surface than you might expect. On the inside edge, you'll notice a thin rim. That's called the flange. It's a small detail, but it plays a huge role in keeping trains safe. It kind of sticks out a bit, almost like a collar, you know? This little lip is easy to overlook, but it's actually a silent guardian for every train journey. Now, the flange isn't really for everyday steering. When a train is rolling along a straight track, the flange just tags along for the ride. Most of the time, when a train's running, the wheels barely touch the flange at all. It's almost like it's not even there, quietly waiting in the background. The real guiding is done by the shape of the wheel and the rail itself. The wheels are actually slightly tapered, which helps the train stay centered on the track as it moves. The flange is there just in case, like a backup for sharp curves or emergencies. When the train hits a tight bend or faces a sudden jolt, that's when the flange steps in. So, if the train starts drifting too far to one side, the flange bumps up against the rail and, well, that stops the wheels from sliding off. It's a simple but brilliant safety feature. It's a simple idea, but it really works. This tiny ridge can make the difference between a smooth ride and a dangerous derailment. The flange is like the last line of defense. When all else fails, it's there to keep the train on track, literally. Without it, even a small bump could send a train right off the tracks. Imagine the chaos if this tiny part wasn't there to catch mistakes. But thanks to this clever design, the flange usually stays out of the way, letting the wheel and rail do most of the heavy lifting. It's a perfect example of how sometimes the most important safety features are the ones you barely notice. One of the most amazing things about train wheels is how they self-center. What that means is the wheels naturally move back to the middle of the track if they start to drift off. The secret behind this is the conical shape of the wheel. So if the train shifts to one side, the wheels ride on the wider part of the cone on one side and the narrower part on the other. This makes one wheel roll just a little farther than the other with every turn. And since both wheels are locked together, this difference gently nudges the train right back to the center. The whole process is smooth and automatic. No computers, no sensors, just good old-fashioned physics at work. This self-centering thing keeps the train stable, even at high speeds or on rough tracks. It's really a quiet hero in the world of trains. Even with great design, rails and wheels really take a beating, you know? Every train is heavy and every trip just adds a little more wear. Over time, wheels can get these flat spots, and rails might end up with cracks or dents. Engineers work hard to keep everything in top shape, let me tell you. They use special machines to grind wheels back into their perfect cone shape. Rails are checked often and replaced if they're worn out. This regular maintenance keeps the trains running smooth and safe. Modern trains also use sensors to watch for problems. If a wheel or rail is wearing out, the system sends an alert. Quick repairs mean fewer accidents and delays. It's a never-ending job, honestly. But every checkup and repair helps trains keep rolling for years. Trains carry huge loads, no kidding. From grain and coal to cars and people, The weight is just enormous. The design of the wheels and rails is what makes all this possible. The steel-on-steel system is super efficient. Wheels roll with little friction, so trains can move massive weights with less energy. The conical shape keeps things stable, even around fast corners. The rails spread the load, so they don't bend or break. Without this smart design, trains would have to go slower, carry less, or stop more often for repairs. The whole system works together, allowing faster speeds, heavier loads, and safer journeys. That's why every tiny detail matters, from the curve of a wheel to the shape of a rail. Engineers never stop looking for ways to improve, you know? Today, they're working on even better wheels and rails. Some new rails use stronger steel or special coatings to reduce wear. Some wheels have sensors built in to track heat and stress. High-speed trains need even more precise shapes. Engineers use computers to design wheels that are smoother and lighter. They also test new rail shapes for faster speeds and quieter rides. There's even research on rails that heal small cracks with special metals. The goal is always the same: safer, faster, and more reliable trains. The future of railroads is bright, thanks to constant innovation. It's easy to overlook railroad tracks, isn't it? They seem so simple, just two lines running into the distance. But hidden in those rails and wheels is a masterpiece of design. This system moves billions of tons of goods every year. It connects cities and countries. Trains help build economies and bring people together. All of this is possible because of smart choices made long ago and the hard work of today's engineers. The next time you see a train gliding by, remember, it's not magic. It's smart, careful engineering. Flat wheels and flat rails would never do the job. It takes a little genius to keep the world on track.